I hope recording is started, right? Please check. Hello? Hello, students? Yeah, thank you. So let us discuss about procedures and the processes they generate. So far, we learned about operators, expression, composition, nested composition, and then defining names, that means defining variables, and then writing the procedures in an abstract way. We can also write complex procedures, right? And we can write recursive procedures to imitate iterative process, right? So as the Lisp does not have any control structures, while for, but we can by calling the procedures repeatedly, we can simulate iterative structures, right? So that's what we discussed. Okay, and now you can I ask you whether you are a good programmer or Lisp programmer? Are you a good Lisp programmer or not? Okay, so far you know simple things, but in order to become an expert, okay, you have to understand the terms processes. Whenever you are calling a procedures, what is happening inside? Okay, the processes are created. Okay, so each process will be generating other processes, and other processes will be generating other processes, etc., etc. And indefinitely, sometimes the process will call other process. The process will give a birth to other process. The child processes are created. Okay, finally, something we will come to an end by using the if statement, right? And that end, you know what is happening, right? So if you want to write a program, okay, which will be generating the process as per your expectation. Okay, actually, if you take a factorial, how will you write a factorial function in Lisp? Okay, and we have gone through many programming languages, how the factorial is calculated, right? So factorial in the sense what? That is n factorial is nothing but n into n minus 1 factorial. And we can also say that if it is 5 factorial, it is nothing but 1 into 2 into 3 into 4 into 5, right? So how to do the logic? 1 into 2 you will perform, and then that result will be multiplied with 3, then that result will be multiplied by 4, and so on. So this is the explanation you will give, right? So for a given problem, we can also write different ways of programs or coding, right? Okay, now in order to have become an expert, you have to know the process shapes. Okay, whenever you are calling the procedures recursively, how the processes are generated, in which shape the processes are created, and finally how it is evaporated. Okay, so let us see that one. Okay, so now after this particular session, you can able to write a program. Okay, by keeping in mind, I want this process to be taken place inside my computer. Okay, for which I'm going to write a recursive program. Okay, so I'm saying that the shape of the process, what is the meaning of shape of the process? Let us look at. Okay, so let us take n factorial. You have to write a program for calculating n factorial. N factorial is nothing but n into n minus 1 factorial, right? So if I ask you to write a Lisp program, you will write like this, defining factorial, which will operate on one argument, and you will recursively call n into factorial of n minus 1. For termination, you will have a base condition. If n equal to 1, return 1. Okay, so for this kind of procedure definition, can you give a process, how the process will be evolving? For each procedure, there are processes associated. Process in the sense what, how the computer is going to solve this particular procedure and giving you a result. Okay, so what you will say, so it is already you have learned in many languages, many subjects. For example, I would like to calculate for 6. Okay, 6 factorial I have to calculate. So considering n as 6, okay, how the flow goes, how the process is generated. So what will happen? It will check is equal to 1 or not. 6 is not equal to 1 and go to the statement n into factorial of n minus 1. That is 6 minus 1. So n into what is that? 6 into factorial of 5. Right, so and then once again it is calling the factorial with n equal to 5 and 5 is not equal to 1, so that 5 into factorial of 4. So this is the way we used to explain, right? But really if you look at what is happening internally, okay, so now for different values of formal parameter, the factorial is called. Right, what is happening inside, how the interpreter is remembering the previous value, right? So you may be thinking about a stack. This is what we have been taught, right? So this kind of procedures will consume much memory. That is, you have to recall what is the value of a previous iteration. Right, so what is happening here, 6 into factor of 5 and then 6 into 5 into factor of 4, 6 into 5 into 4 into factor of 3. So you have to remember the previous state, how the previous state is remembered by using the data structures. So each and every interpreter or compiler, it may have its own, but we know that definitely for a recursive function, the data structure what is used by the system is stack. Right, so the remembering the previous status required for the calculation of recursive versions of the problems. Right, so now let us take and assuming that n equal to 6, you will be end up saying like this. Right, you will be end up saying like this. So 6 into factor of 5, 6 into 5 into factor of 4, all this happening. Right, so till what? Till factorial of 1. So now what the Lisp interpreter does, the Lisp interpreter substitutes a value here. So it uses the substitution model. There are two substitution models we already discussed, that is applicative order substitution model and a normal order substitution model. Right, so according to the substitution model, what happens is factorial of 1 is nothing but a 1. Here it is substituting. Okay, and the inner parenthesis is calculated 2 into 1 and that result is substituted in this place, and then that result is multiplied with 3 and it is substituted here, and that result with 4 and so on. Right, so now if you look at the process, you just think about the process. For a given value, what is happening? There is an expansion, right? It is calling the function many times, and if you look at, there is an expansion occurs, right? You will be getting an expanded expression, right? And then what happens? Due to the substitution model, and it is contracted. Right, the values are the expansion is contracted here. Right, finally you will get a single value. Right, so the expansion and then contraction is the shape. Right, so this type of recursive process is called as a linear recursive process. Why you are using a linear word? What is the meaning of linear word? Linear in the sense here, if n is greater than 6, what will happen? This expansion will be increased. The expansion, that is the number of times expanding, that depends on the value of n. Right, so if value of n is 20, what happened? The expansion is furthermore, it is widened, right? The expansion is more. So the number of expansions depends on the value of n, what you are going to pass over here. Okay, so it is called as a linear recursive process. Linearly, that is n is proportional to the number of factorial calls. Okay, so that's why we are calling it as a linear recursive linear recursion. Okay, and the process what we are calling is a linear recursive process. Okay, so this is the shape of one particular process. Okay, so if I write a program like this, and what is the shape of the process? Expansion and then contraction. Okay, the expansion and the contraction is depending on the number what you are going to pass to the processor argument to the function. Okay, so this is one shape. Okay, now let us go for the other kind of programming. Okay, and if you look at this, define factorial n, and what you are doing, you are calling another function. What is the name of the function? Fact itr. Okay, is another function I have defined here, and 1 n. I want to find out factorial of 6. So what is happening? It is calling fact iter with 116. You look at this particular content of the procedure and what you are understanding, whether you can achieve, you can calculate the factorial or not. Can you calculate the factorial or not? Let us look at, see, fact itr 116. It is calling fact itr, and now there are terms like product, counter, max count. So, and if you look at the logic, counter is greater than max count, return the product. Otherwise, call the same procedure with different arguments. What is that? Now, the product is nothing but counter into product. And the second argument, if you consider, counter is nothing but counter plus 1, and max count is nothing but n. So now, can you define the process involved in this particular procedure? This procedure will not use the process what I explained, that is expansion and contraction. Surely the process is not expansion and contraction. But what is the type of, what is the shape? What is the shape of the process generated by this procedure? Anyone of you, can you please tell me what is the interpretation? What you are doing after all? Students, are you there? Am I teaching only to the computer? Students, can you tell me the logic, what is involved in this? What is defined over here? Students, please respond. You may be wrong, no problem. Just make an interactive one. Students?
Ma'am. Yes.
Yeah, thank you. Thanks for your response. Okay. Yeah, so how to compute factorial? What is the logic of this one? And the previous case we had n into factorial of n minus 1, that concept. But here, is there, that concept is implemented? N into factor of n minus 1? No way, right? I'm not
1 into 1 plus, I mean, in that way it is counting. 1 into 2 into 3 into 4 is the max count.
Yeah. Correct, you are right. So 1 into 2, okay, and then that result will be with the next number, etc. So if you look at this one, what are the values we have to remember? We have to remember the product, and every iteration, the counter has to be incremented. Okay, so there are two processes, right? So now if you look at this one, fact of 116, you take the same example. What is happening? It is calling fact of idea, product is 1, counter is 1, and max count is 6. Now you will check if counter is what? 1 is greater than 6. 1 is greater than 6? No. So it will go to fact ITR and counter into product. What is that? 1 into 1. So 1 into 1. Okay, and then counter becomes 2. So product is 1 and counter is 2. And next time what happens? Counter is 2, product is 1, 2 into 1, and counter will be 3. Right? So every time what happens? That is, it is multiplied. Okay, and we are getting a new product. Right? Counter into previous product. Okay, counter is the new state and product is the previous value, and we are multiplying and substituting for the formal argument product. And also you look at the counter is every time it is incremented. finally what you are returning it is a product, the value of the product. So now this is the different way of solving the problem. Okay, now you please tell me, is it a recursive process? Okay, is it a recursive procedure? Can you tell me, can you define, is it a recursive procedure? Procedure means what I have defined here. That is a procedure factorial, and inside the body, it is calling another procedure. And if you look at another procedure inside the body, you are calling the same procedure. Whether it is a recursive version, is a recursive program, a function that calls itself, that is a concept, right? So now the fact ITR you have defined, it is calling many times. So yes, I have a recursive procedure. And if you look at the process, what is the type of process? What is the shape of the process? Right? The shape is not the expansion and contraction, but what is the shape? Okay, let us look at. Because so factorial of 6, what happens is the first it is calling fact iter of 116. Okay, and another time if you look at what happens is counter is incremented 1 2 6, and when you are calling next time 2 3 6, right, 6 4 6, this is the way it is going on. Finally the product is 720 is returned, right? So what is the shape of the process? What is the shape? It is not expansion, it is not a contraction. Okay, but what happens here? It is maintaining 3 variables. Okay, one is for the product, another one for the counter, another one is nothing but the value, the n, for which we would like to compute factorial. Right. So when you are calling the second time fact ITER, what happens is the counter is incremented and sometimes the product may be modified, and every iteration it is going to memorize only 3 variables. But look at this process. How many things it has to memorize? 6, 5, 4, 3, 2. All those things to be memorized by the interpreter. Right? It has to say in some way. But here, in this particular thing, only 3 variables. Only 3 variables the interpreter has to remember. So you tell me which one is very advantageous, whether writing a program which will produce a process in this fashion or in the as that of previous fashion. You want this shape or you want this shape. Which one is advantageous? Which one is very effective? Students?
Linear iterative process.
Linear iterative process. See, though I have used recursive procedure, the process what I am simulating is iterative process. Right? So what is in the iterative process? What will happen if I am solving the same problem by using the while loop, while constraint? While I is less than n, what I will do, and I will keep product P is nothing but B into I. Okay, so in the control structure, what you're doing, you're just manipulating the variables. The same thing is happening here. Okay, and these 3 variables, status, okay, so consider the current state 2, 3, 6, and the state of these variables depending on the previous state. What is meant by state? That state is nothing but the value what is available at particular time t or t minus 1, whatever. So the state of a particular variable depends on the state of the previous state, right, of the same variable, right? That is why it is going on. So in the previous state 1, 2, 3, okay, 1, 2, 6. 2 is for what? It is a counter. And now 3, how it came? You are incrementing the previous state, that is 2 plus 1, so that you are getting it. And what is that product? The product is based on the product and the counter of previous state. Right? So now I can say this is iterative process. So you can't think that, you should not think that whenever you are calling whenever you are writing a recursive procedure, you can't think that it is an expansion and contraction, but we can also simulate an iterative process. Through a iterative process, what is the advantage? What is the benefit? Through a iterative process, I can save the resources of a computer. The resources of a computer. Resources here, what is that? It is a memory. right? I no need to save many values, but here only 3 values I can able to remember. So that is advantage. Okay, but are you saving in terms of a CPU computation? Can you compare this particular procedure with the previous one? In terms of computation, anything are you saving here? Okay, if you look at counter, there is a multiplication, right? Counter into product. Here also there is a product. So surely you have to do the multiplication. And counter is incremented. Here, is there anything like that? Is there anything like that? After all, the n value is decremented, right? Substitution is happening, decrementing and substitution is happening. So you have a decrement operator here and you have increment here. Okay, so the CPU computation wise almost it is same, but the memory wise we are saving. And moreover, keeping track of a small number of variables in a memory, it is saves. We can able to write an effective program. Okay, so now, okay, this is the thing. There are 2 processes we explained. One is the expansion and contraction. Another one is simulating the iterative process. Okay, and in the iterative process, the state of each and every variable depends on the previous state. Okay, I would like to tell you one more advantage of writing this program. Consider you have a call, right? And in this time, after calling to fact ITR with 236, after this, your program is terminated due to some reason. Okay, maybe power failure or something. Okay, because of other process suspended or something. Okay, so now can you resume back with this? So what I'm saying is your process is stopped at this after calling, nothing happened, okay, but due to some reason, okay, but you want to resume back. Will you start from the beginning or can you start from the previous state where it left off? It is like a database system. Taking a bookmark, right? And there is a breakpoint. And from the breakpoint, you can resume back. That is a concept we learned in DBMS. So the same concept shall be applied here. Somewhere there is an interruption. And you no need to start from the beginning. And from some point where it left off, from there I can continue. Is it possible here? Is it possible, students?
Yes, ma'am.
Yes, it is possible. Why? Because we have saved the previous state of 3 variables, that is counter, product, and n. It is already available with us. Okay, and you start calling the fact ITR with that value. Next time, don't call the factorial 6. Instead, you can call with the fact ITR 236, where 236 is already in your memory. Okay, so that is the benefit of writing this kind of recursive procedures. Okay, but if you look at this one, is there any point if something happens in the middle? Okay, so 6 into 5 into, and after that something happens. So this is not happened, some interruption. Can you resume back? Not possible at all. Not possible at all. Okay, so that is advantage of this one. Right, and in the previous case, what happens is you are pushing a value, pulling the popping the value, pulling the value. I can say also, right? So there are many actions are happening, right? You have to push it, you have to pop it, right? Many time pushing and popping happens. So computation time is also higher in this, right? It will take much time. But here we have only 3 variables. So after all, if you want to look at 3 variables, that's all. What is it, right? So in this way, we can increase the efficiency of the program. Okay, so now we can able to actually in your mind, I want this process in order to write the optimized code. Okay, and now there are 2 processes. I should not go to this process at all, expansion and contraction. I should not go at all. So that is in your mind. So by keeping in that mind, you are writing a procedure, recursive procedure. Okay, so what is happening while writing a procedure? You are also keeping in your mind the shape of the process. Okay, which shape I want, because you know some of the shapes are very efficient. In this case, this shape, linear iterative shape, is very efficient, you know. So you are dictating to the computer, okay, you are dictating to the computer by writing the procedure that I want this shape of the process. My process has to be in this shape only. You are dictating to the interpreter. Okay, so don't blindly write the code. Okay, you have to know the internal processes. What is happening for my each and every call? What is happening in the computer? The interpreter, what it does. Understood? I hope you understood. Right.
Yes, ma'am.
Okay. Yeah. So now let us take this particular problem. Okay. What is happening here? Let's say there are two procedures. Okay, for adding two positive integers. In terms of the procedures, inc, yeah, inc is there, and which will increment the argument by one. Yeah, argument is incremented by one, and the decrement which decrements its argument by one. So actually this is a built-in, consider it is a built-in function. Increment means it will increment, decrement means it will decrement by one, and I have a code like this. Okay, and now how will you validate this expression? You are passing plus 4 5. Okay, and if you look at this one, define plus AB, yeah, so A is 4 and B is 5, and what is happening according to this logic? If you take this one, what is happening according to this logic? Can you just tell me the process generated by these statements? For the first one, you take this logic, and second one, take this logic, and what is the process generated for this procedure for the actual values 4 and 5 for A and B arguments? Can you find out? Yeah, you should be into here now. You quickly apply 4 and 5 instead of A and 5, and you just proceed further. What is happening? Can you write a process diagram like this? Okay, or like this, how it happens? Okay, you just naturally follow the statements. You naturally follow the statements given here. And finally, you tell me what is the shape generated. Yeah, please work on. I may call you randomly. You can take a piece of paper and you can write. You can take down the statements. The first statement is A equal to 0, B, otherwise you have to increment. In the increment, you have a decrement, decrement A and then add it to B. Okay, I'll point out someone. Ashwin. Ashwin, are you there? Leaving. Many people are leaving. You have a fear, then you can't learn. Okay, shall I call Rohit? Rohit Kumar? May I know how many of you are working on this? I show you once again. I hope you understood. There are two procedures for doing the same thing, adding two numbers, right? What you have to do is you have to substitute 4 and 5 for A and B and decide and know what is the shape of the process, whether it is expansion contraction or it is iterative. Understood, right? Please work on, students. If the teacher is always teaching, nothing will go inside, right? In the industry, even in the training period, they will teach something and parallelly you have to work on. And the next second you should be able to give an answer. That much alert you must have. I think somebody is ready for that. Shankar. Oh, by mistake. Leaving. Oh my God, that is a very fantastic idea. Leaving the channel. Raise your hands. How many of you are working now? It's a very simple task I have given. See, I have gone to many industry where your seniors were employed there, and the manager was showing us how your students are working. See, like that, the team leaders explaining something parallelly. All see, you may have many peer group, right? There are people coming from different colleges, right? They are all sitting in the round table, and the people, Amrita people, are very into, and they are giving the answer in a fraction of second. They can able to follow the team lead presentation. The presentation is not a oral one way; it is a two way. They are presenting, you have to do it, tell the answer, and next she will tell and she will ask what is your answer. If you are not understanding at that point, right? So the impression will go off, right? Always in the outside, you will show you as a smart student, right? Smart employee, right?
Excuse me, ma'am.
Yes, yeah.
I just traced one of the programs. Like, shall I tell that part? I got
Sure,
9.
sure. Whatever, sure, sure. I appreciate you for coming up voluntarily. Thank you. Yeah.
Like the initially plus 4 5 is called no, ma'am. So then the A is 4 and B is 5. Since A
Yeah.
is not equals to 0, then the process will call increment of plus 3 decrement of A and then B again. So plus 4 5 will be calling increment of plus 3 5. And since 3 is not equals to 0, then the procedure will call plus 2 5, increment of plus 2 5. Then since 2 is not equals to 0, then it will call again the increment of plus 1 5. Then similarly it will go till plus 0 5. Since here in the last procedure, it is, ma'am, expansion and contraction only, ma'am. Since the last one is plus 0 5 and we have A as 0, we will be returning B. So plus 0 5 will be returning 5 itself. Since it has got an increment, it will be incrementing 5 by 1. So 6 will be written from the innermost procedure. And
Okay,
then
okay, understood. Yeah, yeah, very good. Awesome, awesome. So now what you're saying is for this logic, it is using the expansion and contraction. That is your answer?
yes, ma'am.
Okay, okay. So, yeah, so others can justify this. whether it is expansion, contraction. By seeing some few steps, you can able to understand the shape of the process. Okay. So somebody is ready to explain the second process. Take the second one. Who answered? May I know your name, please?
Priya, ma'am.
Okay, thank you. Thank you, Priya. Yeah.
Thank you.
Is there any volunteer to explain the next logic?
Ma'am, the next second one, it's like initially we are passing plus 4, 5.
Okay.
And then it's not, since 4 is not equal to 0, the next will be
5
plus 3, 6.
Plus
3, 6.
yeah, 3 and 6. Yes.
Yeah, since 3 is not equal to 0, and the next will pass plus 2, 7.
Okay.
And it will go on like that, plus 2, 7, plus 1, 8, plus 0, 9.
Okay.
And finally, since
Yes.
A is equal to 0, and it will return B, which is
Okay.
9. That's it.
Okay. So what is the shape of the process? Did you find?
It's gone. It's not a. Expansion. It's not expansion contraction, but.
Okay. Students, tomorrow I may ask you, few of you, you have to explain. Okay, students. So the next we may go for the another shape of the process that is called as a tree shape. Tree shape in the sense you must be remembering this calculation of Fibonacci numbers, right? Fibonacci number series will be generating tree process. Very fantastic, right? This is a third process we are going to discuss. Okay, so let us take the example how to define Fibonacci of n. Right? If n is 0, 0, and if n is 1, 1, otherwise Fibonacci of n is nothing but Fibonacci of n minus 1 plus Fibonacci of n minus 2. Right. So this is a mathematical explanation. In mathematical, I can able to write this process like this. So the same thing I would like to write in Lisp. By seeing this one, we have to remember a keyword can't. Right. So there are multiple cases, right? There are 3 cases. So we can definitely go for the can't instead of if, right? So define Fibonacci of n, can't. If n is equal to 0, return 0. If n is 1, return 1. Else return what? Call fib of n minus 1 plus fib of n minus 2. Right? This is the way we will write. I hope writing the logic in other programming language, you might have practiced for solving this particular problem. Okay, so let us look at this procedure, right? Defining this procedure, what is the process involved? What is the shape of the process? So what happens if we are calling a procedure with n equal to 5? So fib of 5. Fib of 5 will call fib of 4 and 3, and 4 will call 3 and 2, and 3 will call 2 and 1, and 2 will call 1 and 0, where for 1 we have a straight answer, for 0 we have a straight answer. That means the Lisp interpreter will substitute the values, right, for the terminal nodes. Right, so this is the way it will go on. This is another process shape of another shape of the process. Okay, it is always producing a tree. Okay, now can you compare this tree recursive process with expansion and contraction? Expansion and contraction process. So can we explain which one is very efficient? Can you solve that problem by using this expansion contraction process? After all, can you do that? It's not possible, right? by using expansion and contraction. Actually, if you look at here, what happens? It is a expansion only. This side it is expansion happen. This side also expansion happens and contraction happens. So if you take a tree process, what is that? The sub process. We can able to see a expansion contraction shape in both sides, right? Yeah, right? So this is another shape of the process, and we can also write a procedure to simulate this kind of process in the interpreter, in the computer, right? So analysis is very, very important as we are computer engineer. How much space is required, and when you are appreciating some shape, some process shape, you have to appreciate. So in space wise, it is very good. In the number, in the computer CPU computation wise, it is good. Like that, you have to appreciate, right? So let us analyze these processes in the next session. Okay. Okay.
Yes.
Yeah. Because the subject is like this, we can teach like this in this session only, I hope. I hope you are all benefited. And whenever you are learning something, just know what is happening inside. And we can able to write a program to control what has to be done by the computer. That's what these topics are very helpful.